Hello, everyone. Um, so this is our presentation for the Big Data Analytics project for the 2016 fall semester. Our project involves comparing Uber with its competition in similar online services and the traditional taxi services, which is the yellow cab and green cab services in New York City for 2015. For the purpose of this project, we have used the shape file, which is available online at the New York City government website. Along with this, we also have the TLC taxi zone IDs, the location names, and the corresponding borrow IDs, which are available here. The shapefile is available here. The shapefile basically contains the boundaries of the taxi zones in the form of polygons. I'll be talking about them a little bit later. Uh, Along with this, it has the yellow, green cab data, and it has the FHV data. FHV is the for hire vehicle data, which has trip records for the pickup location and pickup time and date for Lyft and other services like Uber, which have sprung up in the past 5 to 6 years. The other place that we get our data from is the GitHub account for 538. We use the Uber data for January to June 2015, which is in the form of a CSV containing four columns: the dispatching base number, the affiliated base number, location ID, and pickup date. The only ones that we're concerned with is the pickup date and the location ID. So we use, let me just show you the code. So this is the code for converting the shapefile to GeoJSON. GeoJSON is the format for geographical data, which is basically a JSON file. I'll show you. This is the JSON file. It contains features, and one of the features that it contains is a geometry. The geometry is the polygon, the shape of the polygon for each taxi zone in New York City in the form of the coordinates of the edges. To convert the shapefile to this GeoJSON file, this is the code. And first, we have to convert the shapefile from the EPSG2263 mode that we found it in to the 4326 mode, which is the standard. And we have to convert the data from feet to meters, which is again the SI unit for length. Um, After we've done with this, we get the GeoJSON file, and then we use this code. This is for the taxi. This is for Uber. It's basically the same code. What this code is doing is it's using the it's so in the GeoJSON file we have the polygons for the different taxi zones, and for each point we find the polygon that that point is lying in, and for this purpose, we're using MapReduce, and we'll be performing this operation in Spark. This is same data for Uber and same code for Uber, and it does the exact same thing for Uber data. Now, there has been a lot of study on Uber data from before, and we are differentiating our algorithm by focusing on Uber and its competition instead of the traditional taxi data with which Uber has been compared mostly. And now I'll get straight to the results that we've obtained. Presentation. So this is the graph of the Uber pickups in the first half of 2015. As you can see that from January to June, the Uber data clearly shows an increase in the number of pickups. There's a huge demand for Uber, and it's continuously increasing. If we see the hourly Uber pickups distribution, we see that after midnight there's a huge drop, which is obvious, and there's a rise in the morning rush hour, and then there's again a huge rise during the evening rush hour. If we see the same data for taxi, we see that it's constant mostly from January to June. In fact, there's a small decline in the number of taxi pickups from January to June. And the taxi pickup for the distribution for every hour is almost the same as Uber. There's a huge decline after 12 o'clock at night, and otherwise, there's a stable number of taxi demand. And during the rush hour, there's a higher demand for taxis. If we plot this both of them in the same graph, we see again, as you can see, the Uber data is increasing, the number of pickups by Uber from January to June, and the ratio of taxi to Uber pickups is decreasing. Um, Comparing them hourly, we see that during the morning rush hour is, in fact, the only period when the demand for Uber is higher than taxis. During most of the other time, the demand for taxis is either higher or equivalent to Uber. So the main area where Uber is picking up, where it has beaten the traditional taxis, is during the evening rush hour and during night time. So this is the Uber data from January to June. We can see the left side is the graph for January, and we can clearly see that there's more red in the graph on the right. The more red there is, the more number of pickups there has been, and you can see that overall there's been an increase everywhere. And from January to June, there has been more increase in the Manhattan area, in the Bronx area, and in the Brooklyn area. There's also been an increase near the airports. Near both the airports, you can see there's more red. Similarly, for the competing services to Uber, this is January data, this is June data. The competing services have had a huge increase near both the airports. As you can see, there's more red from here to here and from here to here. In Bronx, there has been an increase in FHV, or the competing services to Uber, and in Manhattan too, there has been an increase. Um, Talking about the percentage change in the number of pickups and the absolute change in the number of pickups, first we look at the Uber data. In Uber, there hasn't been much absolute change. There hasn't been much increase, and there hasn't been much decrease. It's been constant. There has been some increase, but it's not been percentage wise. The increase hasn't been much. The areas that were being served a lot initially are still being served a lot by Uber. If we see the percentage change in the Bronx area and in Staten Island and near JFK Airport, there has been a little bit change. But when we see the competing services data, this is where it gets interesting, because uh, the competing services have increased a lot in the Staten Island area. The percentage increase has been huge. In the near the JFK Airport area, there has been a huge increase in both the absolute number and in the percentage. And overall, in Brooklyn, in Upper Brooklyn area, and in Manhattan area, there has been an increase. In Bronx, there has been an increase, and in the Queens near the airport, there has been an increase. So we can see that it's not that Uber has been dominant in the increase. The competing services have been increasing at a rapid pace during this time. Uh, what we conclude from this is that Uber should look to expand in other areas where taxi services, where other services like Lyft have dominated now. These include the Staten Island area and parts of Brooklyn, whereas Uber has tremendously increased its services in Bronx and JFK Airport area, which is where other services, the competing services to Uber, should look to expand in the future. Our findings are also supported by the research from Morgan Stanley. They have similarly predicted an increase in Uber, Lyft, and other services, the newer services, and a decrease in the New York City yellow and green taxis. So finally, this is a really interesting observation that we've got from our data. What we did was that we used the k-means method to obtain the top five representatives where Uber service has increased the most rapidly. And we've done a study on the total distance and the total fare for taxis. These is for the six regions that have the highest increase for Uber, and we can see that from January to June, the average travel distance has increased generally for all the regions except for region 4. And while on the other hand, the fare has decreased for all these regions. So this means that the Uber, that yellow taxi is facing greater challenge from Uber. Even though it is traveling more distance now, the price is generally on average falling for yellow taxis. Um, so that will be it. Thank you guys for bearing with us.